In this video, we're going to look at some examples of some of the styles of problems that you could possibly see on your upcoming final exam. A lot of these will focus in on the material from Chapter 9 about hypothesis tests and confidence intervals for means. And that's because we didn't have a test where that material was covered. So it's nice to have some examples of what you can expect. Just to jump right in, the first one says some shoestrings are manufactured to be 24 inches long on average. The lengths of the shoestrings have a standard deviation of 0.05 inches. If a random sample of 64 shoestrings is taken, the probability that the sample mean shoestring length is less than 23.9925 inches is closest to which of the following choices. So there are few keywords here that stick out and tell me what to do. First one is probability. The other is that I have a random sample. And I'm also looking at the sample mean. So when I want the probability of a sample mean, I'm going to use the normal CDF function. We first did this back in Chapter 6. We did it again in Chapter 7. You hit second and vars on your calculator. It's number 2. We never use normal PDF. It would always be normal CDF. And I get to use the normal distribution in this case because the central limit theorem for means is met. I have a random sample. My sample size of 64 is larger than 25. As well, I have mu, the population mean. These shoestrings, all of them are manufactured to have a mean of 24 inches. And the lengths have a standard deviation of 0.05. This 0.05, this is my sigma. This is not referring to a sample. This is referring to all shoestrings. So because of that information, I can use the normal distribution. I can use normal CDF. I have that normal curve. My mean of 24 is in the middle. This should be my sampling distribution. And I want the probability the shoestring length is less than this 23.9925. So somewhere down here below 24 and all the way down. My shading would go from negative E99 all the way up to that 23.9925 where the shading stops. My mean is 24. And because I'm talking about a sample of 64 shoestrings, I don't just use the standard deviation of 0.05. When I'm dealing with a sample and the sampling distribution, I want to use the standard error, which is sigma over the square root of n. We've got to use this 64 somehow. The 64 makes a difference. So my sigma is 0.05. Divide that by the square root of 64, which you could just type in 8 because that's the square root of 64. I hit enter and I see 0.11506 would round to be choice E, 0.1151. Number 2 here is similar. In a classroom where the students have heights that are normally distributed with a mean of 48 inches and a standard deviation of 1.3 inches. And that's my mu and my sigma. A random sample of size 20 is taken. Find the probability, once again, that the mean of the sample or the sample mean is greater than 48.5. So here it tells me that the heights are already normally distributed. And that's a good thing because the components of the central limit theorem are not met. My mean is 48 in the middle. I do have a random sample, but my sample size of 20 is not large enough. But hey, that's okay. They tell me it's normally distributed. I want the probability that the height is greater than 48.5. So here and above. So again, a probability on the sampling distribution, that's going to come from normal CDF. So second bars, number 2. This time my shading, my left bound starts at 48.5, comma, the shading goes all the way to infinity, second E99, my mean is 48, and again, I have to use the sample size. Somehow the sample size of 20 makes a difference. I use the standard error, so I take the standard deviation, which is 1.3, and I'll divide that by the square root of 20, divided by the square root of our sample size. And that gives us 0.0427. Again, probabilities are typically rounded to 4 places. You won't really have to worry about that in the final because it's entirely multiple choice, and they'll already be rounded to 4 places. Number 3 kind of plays off numbers 1 and 2. 3 says there's a population with a mean of 40 and a standard deviation of 2. So that's a parameter of 40 and a parameter of 2. Mu is 40, sigma is 2. What will be the sampling distribution of x bar? That's the sampling mean when n is 35. So we want to know, well, what will the sampling distribution look like? A and B say it will be approximately normal. C says we don't know what it will be. Well, assuming that sample is random, sample size of 35 should be an approximately normal distribution. So I'm going to mark off C and D. It's got to be A or B. Should be normal because that sample size is over 25. All they need to decide, well, is the standard deviation 2 or is the standard deviation 0.338? And again, when you're talking about the sampling distribution, you don't want to use just the standard deviation, but you want to use the standard error, which is sigma over the square root of n. In our case, sigma, the population standard deviation, is 2. I'll divide that by the square root of the sample size, which was 35. And that gives me that 0.338. So B is the correct choice here. Moving along, 4, 5, and 6 are throwbacks to chapter 7 and 8. Some quick reminders. They also apply to chapter 9, 4, and 5. We make inferences about either A or B. We make inferences about population parameters. We're going to use our samples and our statistics in order to make inferences or assertions about the population and its parameters. On 5, which of the following are inferential tools? A says confidence intervals only. B says hypothesis tests only. C says both. Both is correct. You can use either a confidence interval or a hypothesis test to make inferences about population parameters. Number 6 deals with the interpretation of a confidence interval. It's a 99% confidence interval for the population proportion of post office customers who were served within 5 minutes is calculated to be 0.70 plus or minus 0.03. Which of the following is true? Before I go through my choices, I want to write my confidence interval in a way that we've seen fairly often. We haven't really written it this way. Instead, we've taken our 0.70, this is our p hat, this is our sample proportion, and we've subtracted our margin of error, our e. So 0.70 minus 0.03, that would be 0.67. Then we would add those same two numbers, be 0.73. And so this is my confidence interval. I'm 99% confident that the population proportion of post office customers who were served within 5 minutes is somewhere between 67% and 73%. A says we believe about 3% of the customers were served within 5 minutes. Well, we don't believe that. 3% is way too low. We think it's between 67 and 73. B says we believe 70% of the customers were served within 3 minutes. B is out because that's too exact. We don't think it's exactly 70%. It could be 71%. It could be 68%. It's all of these possibilities, so it doesn't have to be exactly 70%. C says we believe our estimate, which is our p hat 0.70, is correct to within 3 percentage points. That is a correct statement. We think, well, our sample proportion was 70%. We know it could be a little bit higher. It could be a little bit lower. How much higher or how much lower could it be? It could be 0.03 or 3%. That's what that margin of error tells us. D is out because it says we believe at least 70%. That means 70% and above. So it could be 70%, could be 80%, could be 90%, could be 95%. But we know 80% and 90% and 95%, those aren't possibilities because the maximum is 73. C is the best choice. Number 7 goes back to what we saw in Chapter 9 with means. So the sample of 30 local psychologists practicing in family therapy was taken to estimate the mean number of patients per psychologist for that one summer. The sample resulted in an average of 15 patients and a standard deviation of 3 patients. Find the 99% confidence interval for the population mean number of patients per psychologist. So I want a 99% confidence interval for means. So that's going to tell me a lot. Your final exam will be cumulative. It will be over all of our chapters. And it's designed for you to use your calculator to be efficient in your calculation. So I want a confidence interval for a mean. So confidence interval, that phrase tells me I'm later on in our course. We didn't see confidence intervals until Chapter 7. And for a mean, well, that didn't appear until Chapter 9. Chapter 7 and 8 were about proportions. Chapter 9 was about means. So to find the confidence interval for means, we scrolled down the list. It was number 8, the t interval. We're going to use the t interval for this case. I select that. In this case, I don't have the data. I don't have the results from all of the 30 local psychologists, but I do have the statistics, the stats. So I'm going to select stats. X bar, that is my sample mean. Well, the sample resulted in an average or a mean of 15. S is our standard deviation from the sample, which was 3. N is our sample size, which is 30. And we want a 99% confidence level. So I'll change that to 0.99. Hit enter to calculate this. And there is my 99% confidence interval for this population mean number of psychologists. So it would be 13.49 to 16.51. So based off of these 30 psychologists, based off of this sample, I would say the average number of patients per psychologist is somewhere between 13.49 and 16.51. That's where the average is. Final one for this video, a 90% confidence interval for a population mean was constructed to estimate the mean number of milligrams needed of a certain drug to bring relief, as reported by patients in a controlled setting supervised by a physician. Our interval is calculated to be 600 milligrams to 800 milligrams. So that's my confidence interval. I want to know, well, what is the margin of error to report? What's it closest to? Is it 200 milligrams, 100 milligrams, 33, 50, or 1.645 milligrams? So this interval, 600 to 800, this is for a population mean. The average amount of this drug needed to bring relief was somewhere between 600 milligrams and 800 milligrams. To get this, we took X bar and we subtracted E, that gave us the 600. We took X bar, the sample mean, and we added the margin of error, and that gave us the 800. I want to figure out, well, what does this E have to be? I can first off figure out what the X bar is by averaging the two numbers in my confidence interval. I take 600 plus 800 and divide by 2, that's going to give me 700. That's right in the middle of 600 and 800. So it's 700 minus some value and 700 plus some value. That value would have to be choice B, 100 milligrams. If you take 700 minus 100, that will give you the 600. If you take 700 plus 100, that will give you the 800. These are just a few examples of the styles of problems that you could see from Chapter 9 and a little bit from Chapter 7 and Chapter 8 on the final exam.